Hi guys, very good morning. Okay, so this is for all those people who have not attended or missed somehow day one of our series. And so on day one, we have seen what is hypothesis testing, types of hypothesis, and why do we use hypothesis testing. So let's start with what is hypothesis testing. Uh, some of you might already be aware of what is hypothesis. I guess in our plus two and in our college as well, we used to study make an assumption kind of thing, and we'll use to make an assumption and we name it a hypothesis, right? So again, hypothesis testing is a statistical method that is basically used to in making statistical decision using experimental data. So we have made some conclusion. Let's say I predict that my average age of my area is equal to the average age of the country. Let's say this is a statement I made. Now, what I will do in order to prove this correct, I will make some assumptions. I have made some assumption, and then I have the some sample data. Okay, I have the data of the average age of my area. I have the data of average age of uh, the country, right? So what I will do, I will take the sample data out of the bigger data, and then I will perform hypothesis testing. Now in what we do in hypothesis testing, so there are basically two type of hypothesis: H naught or null hypothesis, or alternate hypothesis represented by H naught and Ha. In null hypothesis, we'll assume that there is no relationship between or no association between the groups. That is the opposite. Like there is the average age is not equal. This is would be a null hypothesis. Other hypothesis, alternative hypothesis would be there is a relationship between, or the average of average ages are equal. Okay, so these two hypotheses or statements basically we assume. Now will how we'll go about these statement? Let's see that. uh, that is what we will see in today's day two. So that till now, till this point, we have studied in yesterday. It was in much detail, but in short, this was the thing. Why do we use hypothesis testing? Because and what is the condition of making the two hypotheses? The two hypotheses should be mutually exclusive, like either the average age is equal or it is not equal. Okay, there can't be any third case, right? Let's say there is a match between India and Pakistan. I took this example yesterday as well, and there is no tie or draw system. So let's say if uh, either India will win the match or Pakistan would win the match. Okay, so there is nothing in between. Either they both are exclusive events or statements. Okay, so that is how we choose hypothesis basically. Yeah. So why do we use hypothesis? In order, there is some theory which says that we are good at since it is a sample data. So if we prove false to the sample data, we can assume it for the bigger chunk. But if we make it true for a sample data, we can't assume it true for the bigger chunk. So that's why we go about hypothesis testing, all of those things. Yeah, Google Collab. Yeah, exactly. Yesterday we coded on Google Collab, Numpy, Pandas, Matplot, everything we covered on Google Collab. Okay, yes. I see some familiar places from yesterday itself. Hello guys. We were just discussing what we have studied on date one. Okay, cool then. Yeah, very good morning to everyone. And if you are ready, we can start with day two of our session. And these are the things we needed to cover on day two. We have gone through the basics of hypothesis testing. In day two, we would look into how to test hypothesis testing using Python. Okay. Okay. Night. Okay. Cool. Uh, then we'll go about different types of error. And some couple of tests we'll cover, like t-test or chi-square test. Okay. And then we'll go about some resources and references as well, what which I use for preparing the content. And then we'll enjoy our weekend. Cool then. Let's start with till this point we have covered. So let's start how to test a hypothesis in Python. So yeah, okay. So there are 5 main steps in hypothesis testing. Uh, First is state your firstly will make H0 or H1 or H1 or HA, you can say it. Some books or some content refers to write it as H1. We can use it as HA. HA H0. HA and H1 refers to alternative hypothesis, and H0 is the null hypothesis. Okay. So firstly, we have our hypothesis that average age is equal. Average age of my area is equal to average age of the country, and we'll assume now we have to make two hypotheses, at null hypothesis and alternate hypothesis. So we can assume any of the two mutually exclusive statements as each hypothesis. Okay, so this would be our first step. The second step would be to collect the data in the way it is designed to test the hypothesis. So second step is collection of the data, sample data, you can say, from the complete experimental data. Third is to perform appropriate statistical test. Okay, we'll see what different type of statistical tests it is required and we can do. Okay, fourth step would be decide whether to reject or fail, or to reject null hypothesis. Basically, to reject or approve the null hypothesis. That is what we'll do in fourth step. And fifth step is present the findings in your result and discussion section. Okay, so we'll write some findings. There are some values like p values there. Okay, alpha value, alpha we have to take. So all those things, once we are done, we will present all those things in our result and discussion section. So this is how it will complete our hypothesis testing part. Cool. So these are the 5 steps we need to follow. We'll again come back to that before we go in much detail of each steps. There are few terms which I thought I should explain you before, because to make everyone on the same level. Okay, so as you can see on your screen, there are two terms, level of significance and the p-value. These are very two important terms. Please listen it carefully. How For the people who have joined this for the first time, and I'll tell you what how we go about in this series is, uh, you have the chatbot open. You can ask your doubts in the interval of the session, but what I would prefer you is, please wait till end of the session. If you have anything, you can ask. I'll share my profile as well, and you can chat me on LinkedIn. You can mail me as well. And if after the session you gone through in details of hypothesis testing and you find something interesting, you can share with me. Or if you find something which you are not getting the resources for, you can reach out to me, and I'll try to help you in the best way possible. So that is how we'll go about in this session. Okay, and if in case you want to speak something, you can raise your hand. I'll unmute you and we can have a talk. Okay. Cool then, because there might be some things which I have already planned in my content, and your doubt may be covered in that content till the end of the class, in the end of the session. So yeah, that's the thing. Okay, level of significance. It basically refers to the degree of the significance in which we accept or reject the null hypothesis. So 100% accuracy is not possible, and for accepting or rejecting the hypothesis. So basically now we have to accept or reject the hypothesis, as we have seen in step number 4, right? We have to accept or reject the null hypothesis. But how we can reject or accept the hypothesis? 100, we can't assume that 100% data, sample data, should reject null hypothesis or should accept the null hypothesis. Okay, there should be some level of significance, what it is, what the technical term is, or there should be some lower level or lower percentage with, or lower confident percentage, I would say, to decide whether to reject or accept null hypothesis. Okay, so therefore we select a level of significance that is usually 5%, is what we in industry we assume it to be. Okay, this is normally denoted with alpha. Alpha is a math symbol. You must have seen this like this. It's an alpha, and I'll show you how alpha looks like. So it look like something this. looks something like this, alpha. Okay, so that you should know like how the null hypothesis, the level of significance look like. As I'm muting few people, there is some background noise. Cool. Okay, so this was alpha. Okay, cool then. Yeah. Uh, hmm. So alpha value in when we take 5%, alpha value is 0.05, like it's 105% and it's equivalent to 0.05, which means that your output should be 95% confident to give similar kind of result in each example, in each sample basically. Okay, I hope you got this point. What is level of significance? General value we take 5% and our output should be 95% confident to either to reject or to accept the null hypothesis. Okay, and that level of confidence or level of significance is denoted by alpha. Cool. Now let's come to the p value. What the p value is? P value, or you can say calculated probability, is the probability of finding uh, is the probability of is the probability of finding the observed or more extreme results when the null hypothesis, that is h naught of the question, is true. Okay, I need to. Okay, so that is the thing. It's the probability of finding the observed or more extreme value when the results of h naught of is true. When h naught comes true, it we need to calculate by what probability the h naught is coming true. Okay, the definition of extreme again depends on how the hypothesis is being tested. We'll see all those things in much detail. We'll use alpha and p value in our one example. We'll try to code one example in this session as well. Okay, so don't worry about if you're not getting, if you're not understanding the p value to very exact, and don't try to see it very mathematically. Take it as a definition or a theory part, and practice will do in the session. Okay. So let's say if your p value is less than the chosen significance level of significance we have seen alpha. Let's say your p value is less than alpha, then you reject the null hypothesis. Okay. Yeah, we need to remember this. Like if your level p value is less than the alpha, that means the probability of accepting h naught is less than the level of significance. So that is the case when we have to reject null hypothesis, that is h naught. Okay. Uh, so it also means that accept your sample gives reasonable evidence to support the alternative hypothesis. It also means that your sample supports the alternative hypothesis, that is HA, the other hypothesis defined. Okay, so yeah, so that was null and alternate hypothesis. Cool. So yeah, cool then. These were the two terms, important terms before we come into the five main steps. Now, there are again few tests I want to discuss. And so let's come to this type 1 and type 2 error. These are the two errors which generally we encounter while working in hypothesis testing. Type 1 error, this matrix is you must have seen in machine learning. If some of you are working in machine learning or data science, you must have seen it contains false positive, false negative. Okay, all those things. True positive, true negative, all those things it contains in this table, right? So I'll explain you with this. So let's say, please focus on this table only. Let's say in reality, the h naught comes out to be true. In reality, the h naught is true, and the measured or predictive is what we have measured. Okay, this is for us, and this is the reality in reality. Okay, so in reality, let's say h naught comes out to be true, and we have measured it true correctly. We have measured it true as well, so we are correct. Okay, so this is your column, first row, first column. It signifies. Okay, I'll explain again for this one. Let's say the reality is that h naught comes out to be false. Now H naught comes out to be false. This is the reality, and we have measured it true. Okay, now there is an ambiguity. So this comes under type 1 error, that is false positive. Okay, again, let me explain you again. If that in reality H naught comes out to be true, okay, and the measured value of H naught is false. Now this is again an error, because H naught measured, what we have measured is false, and H naught in reality is true. So again, it comes an error and the type 2 error. Okay. Now F naught, let's H naught, let's say comes out to be false. F H naught in reality is a false. And in measured terms, we come to an conclusion that H naught is false in our case as well. Now this is where we are correct. Okay, that is column 2, row 2. Okay, guys, I hope I'm very clear with type 1 and type 2 error. You just have to remember this table. Okay, and you just have to keep in mind that here is type 1 and here is type 2. Okay, let's quickly move to the definition of type 1 and type 2. So as you can see on your screen itself, these are the errors of type 1 and type 2, which means when we reject a null hypothesis, although the hypothesis was true. When we reject, the null hypothesis, although the hypothesis was true. Type 1 error is denoted by alpha. In hypothesis testing, the normal curve that shows the critical region is called the alpha region. Similarly goes the definition with the beta. Beta we call type 2 error, we call beta. Cool then. So this was type 1 and type 2 error. We'll see, we'll try to incorporate this in our example as well. But yeah, this is what I need to discuss before we go. Okay, cool then. I hope this everything is clear till now. Let's quickly go to the t-test. What the t-tests are there? Look, there are like I think there are 17 number of tests in for hypothesis testing, but currently we would be looking at only two tests: t-test and chi-square test. Okay, so there are the tests like z-test, ANOVA test. Okay, so tail test. So all those tests are also there. Then there is one tail test, two tail test. So all those tests are there, but in our session we are only dealing with t-test and chi-square test. Okay, now I think it would be a good idea to take these two tests after we are done with the steps. Okay, let's quickly come back to the how to test the hypothesis in Python. There are 5 steps. I hope you have got an idea how to reject null hypothesis on the basis of alpha and p-value, combination of alpha and p-value we have seen. How to perform an appropriate statistical test, we'll see that in detail, and present the findings. This you have to document. Okay, and collect the data. You have to collect the data. Okay, so I'll explain you each step one by one with an example, and please be careful with that. Okay, so yeah, let's start with step one, that is state your null and alternate hypothesis. So after developing your initial research hypothesis, I call it research hypothesis because you might have done some research to get the data, and on that data you are predicting something, you are uh, stating something. Okay, so that's the called the your research part. Okay, so after developing your research hypothesis, that is basically the prediction that you want to investigate. It is important to restate it as a null hypothesis and alternate hypothesis respectively, so that you can test it mathematically. Okay. The alternate hypothesis is usually your initial hypothesis that predicts a relationship between variables. But a null hypothesis is a prediction of no relationship between the variables you are interested in. Okay, so let's say I am taking two variable A and B. I am stating that A is related to B. So in alternate hypothesis, it relation can be of anything like A is equal to B. For in our case, we have taken average of area is equal to average of the country. So a so this is assume this as A and assume this as B. So either A is equal to B, any relation kind of thing, equal, unequal, greater than, less than, I'm not commenting on that. Any kind of relationship is there. So alternate hypothesis, we assume that there is a relationship, But in null hypothesis, we assume just opposite to it, that is mutually exclusive. That is, there is no relationship between the variables. Okay. So let's take an example on this. Let's say you want to test whether there is a relationship between gender and height. Okay, so based on your knowledge of human psychology, or physiology, you formulate a hypothesis that men's are on average taller than women to test this hypothesis. So you restate it as, so this is your sample research you want to do. Okay, this is the research you want to do, or investigation you want to do. Okay, so you can assume null hypothesis and alternate hypothesis. This would be your first step. Okay, so in case of null hypothesis, you can say men are on average not taller than women. This would be your null hypothesis. And alternate hypothesis would be men are on average taller than women. Okay, so this is null and alternate hypothesis, H naught and HA. Okay, I hope I'm clear with this. Yeah. Okay. So last example, what we were taking was, let's say, what I have to test is there a relationship between gender and height? Okay, so there is a relationship what I want to understand and what I want to investigate between gender and height. That is, let's say, variable A and variable B. Okay, so in null hypothesis, what we have assumed that there is no relation. So we can say that what I want to investigate in this particularly, that are men's on average taller than women. This is my statement, or stating, or investigation, statement I want to make it true or false. Okay. Now for this, step one would be, uh, let's assume null and alternate hypothesis. For null hypothesis, I can assume that, let's say, men on average are not taller than women. Always opposite I will take for null hypothesis. There is no relation. That is, men are on average not taller than women. But in alternate hypothesis, will support the statement which we want to prove correct. That's why what we in the last step, what we have to prove, or we reject null hypothesis. We don't reject, or we don't accept a alternate hypothesis. We just reject null hypothesis with a certain level of significance, that was and the combination of p value, so that our alternate hypothesis will become true. Okay, so that's how we do. Okay, so H naught would be men's are on average not taller than women, and alternate hypothesis would be men's on average are taller than women. Cool. Then now let's come to our second step, that is collection of the data. Okay, so for an statistical test to be valid, it is important to perform some sampling and to collect the data in a way that is designed to test your hypothesis. So according to the hypothesis, you need to collect the data. It's not like you just have to collect the data. It should be according to the hypothesis that you have assumed. Okay. uh, if your data are not representative, then you cannot make statistical inferences about the population you are interested in. So basically, the bigger chunk we call it a population, and the smaller we call the sample data that we work on. Okay, so we make null hypothesis and alternate hypothesis based on the sample data, not on the complete population. Okay, so this was one thing. Also, the data you are collecting should be uh, kind of representative. Okay, it should be kind of tables or charts or something like that. Okay, that's why we have studied all those libraries in the day one. Okay, so in order to represent that. But again, let's come back to our step two, that is collection of the data. Okay, so let's take an example to test difference in the height, and difference between the height of men and women. Your sample should have an equal proportion of men and women. Okay, and it should also cover a variety of socio-economic classes and other control variables that might influence average height. Okay, there can be other influences that can influence average heights, like uh, it can be based on uh, region they are living. It can be based on the average height of the area. It can be based on the food they consume, or the habits they follow, or like the use cases they use their height for. Okay, so different the height and all those things depend on genes, they depend on the habits we do, they depend on other socio-economic factors as well. So you need to consider those parameters as well in your data. It shouldn't be like this man, this height, gender, this man, this woman, this height, this gender. It should not be like that. It should consider socioeconomic classes. Also, the data should not be, there is a term called uh, class sampling imbalance or class imbalance, which in machine learning, I am sorry, I'm deviating from the topic, but there is a term called class imbalance, which is basically, let's say you have the data of men's more in number and you have data of women's less in number in your data set. So men's is one class, women in another class. So this type of differences is a class imbalance problem. This creates a class imbalance problem because you don't have sufficient data of men or women to test uh, the the model. Okay, so this causes the class imbalance. So there are two procedures to proceed with that. Either do upsampling, like you can increase the data of the women or the men, either with either way you can do. This is called upsampling, or you can reduce the number of the data of, let's say, man or woman, which is lower in number. You can which is more in number, you can reduce that data so that equivalent data we have. Okay, so though these are two methods, upsampling, downsampling. Okay, leave it. Let's come to the step two, that is collection of data. So in order to do that, we should have this equivalent number of men and women, all those things. So you should also consider the scope, that is for one country worldwide, what you are considering the scope. So you should also take that into the consideration. A potential data source, if you ask me, in this case might be the census data that our Indian government, that worldwide is used by different countries. So that can be a potential data source because it's important for us to identify the data source as well. Okay, since it includes data, census data. Why census data? Because it includes data from a variety of regions, variety of social classes, and it is available for most of the countries around the world as well. So we try to look into the data which is open source, which is easily available. Also, it is reaching to the all the type of regions and social classes in the society. Okay, so that is the part of collection of data. So that was our step two. So step one, h not stating null and alternate hypothesis. Step two, collection of the data. Cool. So these are the two steps. I hope this is clear. Yeah, no worries. Okay. Mm, yeah, let's move on to our step three, which is perform an appropriate statistical test. Okay, now there are a variety of statistical tests available, but they are all based on the comparison within group variance versus between group variance. I'll explain you both the terms. Within group variance means how spread out the data is within the a category. How spread out the data is within, let's say, how spread out the, let's say, let's take an example of men's height. Okay, so men's height, it should not be like the men's, all the men's are having the data we have taken. The height of the men's would is between, let's say, 6 foot 6 and 6'5". Okay, 6 foot and 6'5". Okay, it should not be between the most of the data, let's say 100 data of men's we have taken, so 90 of them sits around 6 and 6'5". Okay, and the 10 are distributed between above that, some 1 2 are above that and some are below that. So the concentration of the data is within the group variance. So this is called within the group variance. And between the group variance means how different the categories are from one another. Like the categories should be different, right? In this case, but in our case, the datas are mostly would be different, like men's and women's. Okay, so they would be between group variances will be more, right? So we have to take care of in within group variance as well. So statistical tests are basically based on that. It's like that. The statistical test that we will perform would be based on these two things: within group variance and between group variance. These are the two things. Also, so if the between group variance is large enough, let's say the within group variance is large enough, so that there is a little or no overlap between the groups, variance is comparatively large. Like variance is large, uh, we shouldn't go into much detail of the statistics because that's again a complete topic for the 2-3 hour session. But variance, I hope you understand what variance is. Distribution of the data, you can say how the data is divided on points to points. Okay, something like that. So if the variance is more, just understand that if the variance is more, there is a good spread of the data across all the values. Okay, it's not like 90 people are having the height from 6 to 6'5". Okay, if the variance is large, the data is pretty much widespread, that there is no or little or let's say no overlap between the groups, and then your statistical test will reflect that it is showing a low p-value. If the group variance is large, it will your statistical test will reflect that it is having a low p-value. Okay, this means it is unlikely that the difference between these groups came about by a chance. Okay, alternatively, if there is high within group variance is high. Look, that was between group variance was high enough, that is between the two groups, like men and women. There is no overlap, there is little overlap. This means that your p-value would be low. If your p-value is low, there are high chances that alpha might get the null hypothesis might get rejected or accepted. Cool. Alternatively, if there is a high within group variance, okay, and low between group variance. Okay, now understand this use case. Let's say there is a high within group variance, like within the group, within men, within women's, there is high group variance, and but there is a low group variance between the groups. Between two groups, there is low uh, group variance. Then your statistical test will reflect that your statistical test will reflect that, and it will reflect using the high p-value. Okay, this is something you need to remember. Okay, kind of. Also, you can go dive in detail of p-value, what p-value signifies, and in terms of group variances, and you can look into that. Okay, this means it is likely that any difference you measure between the group is due to chance. Okay, so in short, your statistical test will be based on the type of the data you collected. Okay, so depending on that, you have to do the statistical test. Okay, I hope I'm clear at till now. And yeah, we'll take an example, Nupur, and let me know if after that it's clear for you. Okay, so let's take the same example what we were taking from last two steps. Based on the type of the data you collected, let's say you perform a, a type of test. Okay, x type of test you perform, whether the men's are in fact taller than women or not. Okay, so now this x test, let's say x, I'm calling the test as x. Now let's say this x test gives you an estimate of the difference in average height between the two groups. Also, it is showing a p-value which is likely to see this difference if the null hypothesis of no difference is true. Okay, it gives two value. Basically, you perform a x test, it gives you two value, an estimate of the difference in average height between the two groups, men and women. Okay, the second thing it is giving a p-value showing how likely you are to see this difference if the null hypothesis of no difference is true. That is, the null hypothesis of no difference is true, how likely you are able to see this. Okay, basically that is what a p-value tells, that how likely or what is the probability of null hypothesis is true. What is null hypothesis? Is there a relationship or is there a difference between uh, the two groups we have taken, right, or the two variables we have taken, right? So that's what a null hypothesis. So basically, in short, it gives you a p-value and the estimate over the difference of heights between the two groups. Okay, so the x test you perform shows an average height of, let's say, some 175 centimeter for men. Okay, let's take an example of 175 meter for men and an average height of 161 centimeter for women. Okay, so now an estimate true difference is ranging from 10.10 centimeter approximately to infinity. Cool. Like there would be a difference of 10 centimeter and to infinity. Now, thus the p value comes out to be 0.002. Cool. That was the p value we get. Okay. So I hope that was clear with that example. And let's come to let's come to step 4, which says will also, if you are not getting some part, will also do it in the code. And how, if you're thinking how in the coding section or how in the coding part it will be implemented, I assume I tell you that the p value we are currently dealing with, the test we are dealing with, will do this in the code as well. Okay, in the Google Colab itself that we have used yesterday. Okay, in the same Google Colab notebook, will do the coding part of this. Okay, if there is any doubt, I'll take in the end of the session. Till the end of the session, hopefully it will get cleared. Okay, let's take let's quickly move on to step number 4, and then we'll discuss about step number 5, and let's jump to the coding part of this. Okay, step number 4 is decide whether to reject or fail to reject or fail to reject. Basically, decide whether to reject or fail to reject your null hypothesis. This is what we need to decide, because if we reject null hypothesis, we are accepting alternate hypothesis. If we fail to reject null hypothesis, it means we have to accept null hypothesis. We have to, then we are rejecting alternate hypothesis. Okay, so these can be the two cases. Are they again mutually exclusive? Okay. So let's say based on the your outcome of your statistical test you perform, let's say X test you perform, you will have to decide whether to reject or uh, accept or fail to reject null hypothesis. In most cases, you will use the p value that is generated from the statistical test. uh, that will help you to make your decision. Okay, but in most cases you uh, predetermined the level of significance for rejecting the null hypothesis will be 0.05. Okay, your predetermined value of level of significance, that is alpha, for rejecting null hypothesis is zero point zero 0.05. That is what we have mutually understand, and we mutually understood, and we have finalized that let's say the predefined value of alpha for rejecting null hypothesis is 0.05, that is 5%. We have already seen in the definition of level of significance that this is what the general value we take. Okay, that is when there is a less than 5% chances 5% chance that you would see these results if the null hypothesis were true. Okay, in some cases, researchers try to choose a more conservative level of significance, such as 1%. Okay, there might be some cases. Again, the level of significance depends on the type of research you are doing, the topic of research, the sensibility or the sensitive information of the data you are using, the sensitive topic or the statement you are making. So level of significance depend upon that. Okay, and this is something you will get with experience. And experience you can try working on some examples which are available on internet, and you so that you will start getting an idea of the level of significance more in detail. Okay, so why they use a lower level of and a conservative approach of choosing a level of significance, just in order to minimize the risk of incorrectly rejecting the null hypothesis. It's not always like the statement we are making is always true, and we should not have that approach in our mind that this is the statement I'm making and I want it to be true. So anyhow, by hook or crook, I would reject null hypothesis. So you don't have to take, okay, I'll take 95% as level of significance. It's not how the things are going to work. Because if you take this level of understanding and this result conclusion document to your senior or some the let's say client or someone you are reporting to, it will reject that the level of significance is too high, and the null hypothesis, you have not given a fair chance to null hypothesis to come back. Okay, so in order to minimize the risk of incorrectly rejecting the null hypothesis, okay, that if you come back, So that's why we take less level of significance. If you come back to our present our this slide, you can see if it will come into type 1 error, right? It will come into type 1 error that in reality h naught was false, but the measured h naught was true. Cool, leave it. With it was not. Yeah. So this step 4. Step 4 we were on. And let me give you an example. If your analysis of difference in height of men and women, you find that the p-value is 0.02, 0.002, okay, is below your cutoff of 0.05, right? 0.002 is below our cutoff of 0.05. So you decide to reject your null hypothesis of no difference. Your null hypothesis of no difference, you will reject, right? Your alpha is more than the p-value, so we'll reject null hypothesis. Okay. So this is how the rejection part is done. Okay, I hope this step would be the easiest because you have already have the p-value, you already have a level of significance, that is alpha. If alpha is greater, accept. If alpha is greater, reject. If alpha is smaller, accept. Cool. So this was step 4 of testing the null hypothesis, testing the hypothesis in Python. So last and the most important one, that how to present your findings. The result of hypothesis testing will be presented in the result and discussion section of your research paper. So let's say you are writing the research paper, because uh, most of the hypothesis testing you would be doing would be either for client or for your research paper or thesis paper or your, let's say, your patent or something like that. You must be, so there must be a discussion and result section in your research paper that, okay, based on this p-value, this level of significance, I reject the null hypothesis, and this is my finding, that there is no let's say, what the example what we were taking, that there is no difference between, there is no relation between the gender and height. Okay, or if there is a difference between, there is a relation between gender and height, whichever be the case possible, or whichever you get the output. Okay, so you need to present all those things in the result and discussion section. So in the result section, you should give basically a brief summary of the data, a summary of the results of your statistical test. Let's say we, in our case, we assume it as x text. For example, the estimated difference between the group means and associated p-value, all those things you can mention in your result section. And in the discussion section, you can discuss whether your initial hypothesis was supported by your result or not. The initial hypothesis or the statement you started with was supported by your result, or it was not supported by your result. Okay. And in formal language of hypothesis testing, we talk about rejection or failing to reject the null hypothesis. You will probably be asked to do this in your statistical assignments or in your statistical paper as well. Okay, so in our example, what we will write in the result case, so uh, in our comparison of mean height between men and women, we found out that the average difference of 10 centimeter and a p-value of 0.002. Therefore, we can reject the null hypothesis that the men are not taller than women, and conclude that there is likely a difference in height between men and women. Okay, we reject the null hypothesis that the men are not taller. We reject that because the p-value and the alpha value combination comes out like this, and thus our conclusion or our statement, initial statement, was right. Okay, cool. So guys, I think it's okay. Actually, I'm not using the whiteboard. I'm just looking at your screen and then just explaining. I'll give you the proper code base and proper reference link if you want to refer to, for if you like whiteboard. Okay, I'll give you the proper link for that. Actually, I didn't use whiteboard for that. Yeah, that's the case. Okay, so guys, if before moving to the coding part, would you like to take a quick break of 2 minutes so that we can take a quick break of, let's say, 5 minutes, 5 or 10 minutes, and we can come back? Will that be fine? Yeah, we can grab some tea, coffee, or something. Yeah, so I don't think this session will. The only part I think we are left with some tests, couple of tests, and that too are very theoretical. And the coding part, I guess, that would that wouldn't take 10 to 15 or 20 minutes. Although we were supposed to end it by 11 a.m., so we'll end it before 11 a.m. Yesterday we ended, I think we extended the time by a few minutes, but today we'll end it in before time, because yesterday the topics were more, and everything was on zero, on a scratch, so that's why it took more of us our time. But today we'll try to end it before, okay, so that some of our friends from US also don't get trouble. Okay, cool then. We'll take 10-minute break. It's 9:52 a.m. In India. Let's meet at 10:05 a.m. Would that be fine? Nice. A short 10-minute, 10, 12 minutes break. Cool with everyone? Till then, what I can do is I'll share you with the presentation, and you can go through the resources if you want, so that it might save your time as well. Okay, or what I can do is I can uh, share you some link, not the presentation. I'll share you some link so that you can get an idea of a few things here. You can refer to this. GitHub links I'm also sharing, so that you might help you to get the coding stuff after the session. Okay, cool then. Let's meet after 10 minutes, and let's. Okay, guys. So let's start, and yeah, I think hopefully everyone is back and we can start. So yeah, these were the 5 steps we have seen in detail how, but mostly theoretically we have seen all those things. Now let's write some code and start sharing my Google Colab screen. Also, well, for all those people who have joined today itself, I'll give them some ideas on what we have studied part. So this is the Collab sheet, Google Collab sheet. I hope you are able to open that. If in case, let me start from scratch. So you just have to type Google Colab, sorry, and open the first link, google.research.google.com. Open a new notebook, and voila, this is what you will see in on your screen. This is a new notebook. You can code anything, and this is the play run cell button. You can press it. Also, you can use the control plus enter key to run it. Okay, if in case you want to add others key, like you can add, you can type multiple lines of code in the same cell, or if you want to add a separate cell, you can add using control plus m plus b, or you can add here. You can click on and can add as number of cells as you want before, and then you can start coding. Cool. There are two things, like if you run something, either it can turn to red. Okay, if it turns to red, that means there is some error, and the error message will be shown below. And if there is no error, it will come with a small green tick like this, which says their code has successfully compiled without any error. Okay, so that's the thing. Cool. Yeah, so let's so we yesterday we have already created a notebook, and so all those people who were not yesterday, please create your Google Collab sheet. This is what we notebook, this is what we would be using in today's class as well for hypothesis testing part. And yeah, let's jump to the, so basically four libraries we have seen yesterday. One was Numpy, other one was Pandas, third one was Matplotlib, and where it is, yeah, here it is, Matplotlib, and the fourth one was Seaborn. So all these four libraries we have seen, or modules we have seen in yesterday's session, and I'll give you a quick introduction about all those uh, libraries, and we have more than sufficient time to complete uh, our hypothesis testing code part, so don't worry on that. Okay, cool then. Yeah, so if any library you want to install, you need to type pip install and the name of the library. It will install. Since my requirements are already satisfied, it will show you some message like this, that requirements already satisfied. If it gives an error, let's say if I type pip install nump, I hope nump won't be some id. Okay, nump is an id. Okay. I thought it won't be a id. Let's say I gave let's say this, I made some error, I made some mistake. Okay, so this is what it shows like, and a red button will tell that your this comes with an error and syntax error, invalid syntax. Okay, so Google Colab has this very one good already integrated thing that that you can search directly on the Stack Overflow. If you click on it, Stack Overflow with the proper keywords, is because both of them are from Google, are products of Google. So they come with very good keyword space, so that you will get most accurate answers possible for this error. Okay, so and you can search your answer and you can edit it accordingly. So I know the answer. It's like it would be like this. So pip install numpy, requirements are already certified, so this cell will run good. Now in order to import any library, you need to write this import statement, import keyword. After import, you need to press space and then numpy, and then s and np. Okay, so np is like in our code base, we have to use, there would be some methods, there would be some variables related to this like module, like numpy, right? So every time I when I want to enter, when I want to use any method or any variable related to numpy, I have to every time type numpy dot this, numpy dot that. But this would be a bit tedious job to do. So what I have done is I have assigned a short representation of numpy, that is np. I call numpy as np, and so that is how you like, that is how you write. And let's say in pandas I have assigned import pandas as pd, import matplotlib. There was a big library in matplotlib.pyplot as plt. Okay, what this pyplot is, pyplot is the sub module of matplotlib, because the most of the functions that we are using in pyplot, in matplotlib, are contained in this pyplot sub module. So we are using that. Okay, so we are just importing that. We are not importing the complete module. We are importing the sub module of the bigger module, so that it reduces the burden on our code base. Cool, then I think we are good to go ahead, I guess. Okay, yeah. So yeah, let's come where we were. Yeah. So numpy, import numpy as an np. I'll run it. You can see it ran successfully. And now numpy, what numpy is used for, numpy is used for numpy is famous for the array, the manipulation, the all the things we need to do with array. So it's famous for that. And that's what we are doing. We'll use an array function. So np dot array, array, and in the array, this array function converts anything, any list or anything of the continuous form to the numpy array. Numpy array is of the type nd array. I'll show you the type of the numpy array. So it's type arr, and If I run it, so it will show you the type ND array, numpy.nd array. So ND array is the object, type object of the array in numpy. Cool. So this is how we can define and initialize a numpy array. And if you want to print the numpy array, print is the function that we use. ARR is the name of the array. Okay, so print ARR will print the numpy array. Okay, it can be initially it's a list. If it can be a tuple, it can be any other data type as well, but continuous. Okay, cool. So this was NumPy, and let's say I want to see sometimes in our industry, in our when we write the code, we want to check whether we want to verify whether the NumPy version that we are using is the latest one, or is the more required one, or the appropriate one that we require for the particular system or the software or the use case. Okay, so you can use this particular command np dot underscore underscore version underscore underscore, and yeah, that's what you can use, and it will print you the version of the NumPy. Cool. uh, Now pip install pandas. Now let's come to the pandas part. Couple of more examples we have seen on NumPy, not going much in detail because others would get bored much more, so not going in much detail of that. But yeah, this was NumPy for you. Importing NumPy and playing with arrays is what NumPy does. Okay, now let's quickly jump to what pandas does. Installation of pandas, the same thing, pip install pandas. And importing a pandas, import pandas, all requirements are already satisfied, so it will get successfully installed. No worries in that. Now importing pandas as PD will import pandas at PD. Now you can import pandas as PD. I think Google Collab, uh, should we, I think it would work in the same way, because Google Colab is, I think, is a website or web portal, so platform. So I think it would work in the same way, independent of your system and requirements. That's why I use Google Colab. Okay. Also, guys, if you don't want to use Google Colab, if you have Anaconda or a Spider or any other software which runs the Python and machine learning data science code successfully, you can also use that. Okay. I'm using Google Colab because there are different people from different areas and different system requirements as well. So that's why. Yeah. Okay. So import pandas. Now pandas take it as a dictionary. Let's take pandas. Give a pandas a dictionary, and the data frame is what pandas use. It's ND array for NumPy, so it's the same as data frame what pandas library use. Okay, so pd dot data frame, pd again pandas library, so pd dot data frame, it will convert this dictionary into the data frame. Will store it in my where, and print my where, it will print the form in the tabular data. So basically tabular data, dealing with tabular data, dealing with missing values, dealing with all those things you can do. Yeah, it should be, you can do. Again, you need to check the requirements. I have not coded in VS Code this part, but I think you can do. Yeah, can do, but the system requirements you need to check, like some installation of libraries and extensions is might require in VS Code. But once you are done with that, I think you would be able to run these things. Yeah, so look, so dealing with the tabular data on all those rows and columns, we use pandas. Cool. Now, pandas mostly are, since tabular data, now where to get the tabular data from? We just can't keep on creating all those datas. We have to have some external source. We might require some external source, some in some cases, to deal with. So that's where the use of read CSV, read JSON, all those functions of Pandas library came into the picture. Uh, so let's take an online URL, online CSV file. Let's store the variable in the let's make a URL variable and store the online CSV file and that URL as in the form of string, and then we'll pass it in the read CSV function, which basically reads the CSV and pass it in the data frame object, and we can print the data frame object. So printing DF or data frame object completely means it will print all the rows and columns with the numbering part as well. Okay, but if let's say if you want to print only the first 10 first 5 or first 10, or let's say first n number of entries basically, so what you can do is you can use the head part, and if you leave it empty it will print uh, the top 5 entries. If you like write 10 inside it, it will print the top 10 entries. Okay, there is also a tail thing, tail function. If you want to print uh, values from below of the table, like from the last of the table, top 5 below 5 values it will print. Okay, there is also a info function that we used yesterday, and that tells you, that will give you the idea of the data you have, like how many non-null values. This is very important because null values, non-null values, missing values, all those things we have to deal on the daily basis in the data science field and in the data science pipeline. Cool. So info is very important function. So yeah, that was now read CSV. You can read CSV from the local system as well. If you have CSV, you can upload it here. Okay, you can upload it here as well from your local system, and if you have it in the system as well, you can read it, and this is the command for that. Read CSV and the name of the CSV will appear, and the simply the same thing that we have done over using the URL. Cool, I guess. Then JSON you can also read. You can add a JSON file, and you can read the JSON as well. We have done that as well. And, yeah, I think hmm, cool then. Yeah, that was one thing. And yeah, so that was mostly the basics of Pandas for us that we might require in the session. So let's quickly come to the matplotlib. Matplotlib is a library basically which helps you to plot your data in the form of graph, in the form of histograms, in the form of pie chart, in the form of various other methods of visualization. And some of the data analysts working there, or business analysts working there, you might have to give some representation of the data in the form of pie chart, graphs, or pie plot, or histograms, or all those things you might have encountered, and you might have sent it to the business team, to the data science team, right? So you might be aware of the matplotlib, although you might be using some higher other libraries in combination of matplotlib. That we in this course also, in this session also, we have used cbond in combination of matplotlib, so that you must be using in your daily work. Cool. Then matplotlib, again the same thing, importing as plt. Just we are importing the subplot, sorry, pyplot, that is the sub module of the matplotlib. And yeah, let's import that. Let's import numpy, and this x points will give you the array of from 0 to 6, and this y points will give you an array of like this. And the plot function will help you plot x points and y points. uh, Actually, it should be the thing is the pyplot is just a module. We are just naming matplot.pl pyplot, this complete thing as plt, so that whenever we require to access here, like we are require this array function is from numpy. Okay, we want to use it. We want to use this array function from that is already defined in the numpy module or in the numpy library. So we have to write numpy.array. So instead of that, I have renamed numpy as np in our code. This is called alias, and np alias, and I use np as np.array. Okay, so that's why we have used plt for that. Okay, I hope it's just a representation, it's not something different, it's just a representation we have used. Okay, I hope I understood your doubt and clear that. Okay, plt dot plot. Plot is the function that plots on the that helps you plot basically. And plt dot show will help you show on the graph. That's the function uh, you need to remember, kind of, plot and show. And every time in every visualization code and visualization script, you will use basically these functions, and that's how it will go. Okay. Okay, so that was matplot. Yeah. So we have also plotted the pie charts. In that, you can go through uh, the .ipynb file that I have shared in the chat. You can go through that. I have shared that is with the learn Learnbay day one. Okay, and you can look into that. I have also written the code. We have also written the code and discussed the code of plotting the pie charts in that. So yeah, that was another thing. Now let's quickly come to the seaborn, and then we'll go to the our main topic of hypothesis testing coding part. Now, uh, seaborn, yeah. So let's import seaborn and SNS. I'll import seaborn as and matplot pyplot as plt. Now SNS dot displot. This will plot on the graph, and plt dot show, which will help us in showing that. And you can see this is how beautiful it looks like. Now, a couple of more examples we have taken, like we have also used the label kind of thing to label this complete graph that you can find in the sheet. I'm not repeating it again. And this is how to draw a line plot. This is how to load the dataset, iris dataset. I hope you might be aware with the iris dataset. It contains the petals or sepals thing. Cool. So that's how it does. And yeah, so importing package and seaborn. Yeah. So till this uh, we have covered, and you can find the code in the chat as well for all this, and way more in detail we have covered. Cool. Now let's come to the part. I hope everyone is back again, and let's come to the part of hypothesis testing using the code. Let's write the code for that. So we'll start with importing numpy. So importing numpy as np, and I hope it will work. So I'm writing the all complete code in one cell itself. Okay, and then I think we would require pandas. So currently I'm importing all the libraries that we would require. So importing numpy as np and pandas at pd, right? Here you can see the definition of pandas as well as a Python package providing fast, flexible, and exhaustive data structure, blah blah blah. So you can find that as well. Cool. Now let's store the null outcomes. So we'll make a variable with the name null outcomes. Let's store that. This is the list that we are making, like empty list, you can say. Okay. Let's make the observed values. Let's assume that the observed values are 41. You can take any random number. I took 41. Let's say. So let's simulate the null distribution. Let's simulate our null distribution basically to make a null distribution. Okay. So I can write simulate. I'll go about writing the code with the comments as well, so that if in case you read this in the future, you would have the reference like why we have written this. Okay. So this is how you write the comments in Python for all those people who are new to this. So this is how you write the code in Python. The comments generally not uh, generally not executed or on the system. Okay, they are just for the reference of the coder or the client. Okay, simulate the null distribution. A very small example I am taking. where we'll simulate a binomial hypothesis test, let's say X test. We are simulating using the following null and alternate hypothesis. Okay, the null hypothesis that we are taking, we would take is that the probability that a visitor to a website makes a purchase is 0.1. Okay, this is the null hypothesis that we are assuming that let's say we are working in a e-commerce company, and the probability that we have to make, we are asked a question from the client or the business stakeholders that what is the probability that the visitor to a website makes a purchase. Okay, and let's say we stated a percentage of a particular percentage of the purchase that he makes, let's say 10%, 20%. Okay, so now he is asking that prove me wrong, or like prove your answer is correct using the test hypothesis testing, or you have to submit a report mentioning all those things. Okay, so we are doing for that. Okay, so yeah, so what we'll do, we'll take the null distribution of, let's say, um, 1 lakh employees, 1 lakh people, customers, all. So for I in range, I hope this small syntax I don't have to explain you much, right guys? 2 3 4 5. Now we'll write simulated visitors. I would the good choice of the name of the variables is very important while writing the code for all those who are currently studying and will be entering in the industry. I'm just making few points or tips clear for them. Like choose a good choice of the variable is very important, and the name of the variable is very important, so that I could have used X, and it would have X instead of this, and it would have worked fine, completely fine in my code as well. But again, if you are an observer, if someone else is viewing your course or code, or going through your course, it is important. Then we have basically taken it. You can assume it anything. It's a sample data, you can say. A sample data. I told you now, the sample data we take from the big population, we take a sample data. Yeah. Yeah, selecting right variable and selecting the right name for the variable are two different things. Selecting right variable is a part of the pipeline, and selecting the right name of the variable is something your personal choice, or the call you have to make while writing the code. Okay, so there is, I think, a quite difference in between these two things. Okay, cool then. Simulated visitors, let's it would be complete random. So random dot choice and p dot random. I think you are aware with the random and choice libraries. They are very basic libraries where you can see it generates a random sample from given 1D array. Okay, this is the syntax of that. So in the choice there is one variable that we have to define, that is a. Okay, so a would be indent, so we'll define that. Let's say yes or no, y or n. And uh, all those things, all those small, since it's a random data, we are simulating the null distribution. Okay, so all those things that I'm assuming is based on my assumption. You can assume anything you want. Okay, you can perform your experiment, you can take out a p value out of that. Okay, you can assume, you can take out other value out of that, and it would work for you. Okay, so all those things you need to check. Okay, and you need to experiment basically. Size I'm taking is for the simulation uh, would be, let's say, 500 would be good, and the p I would be taking as, sorry, p would be taking as zero point 0.1 to 0.9. Okay guys, let's say the minimum purchase that they have made, or the number of purchase that they have made comes out to be np.sum, and where the purchase would be made when the simulated visitors are yes, right? It comes in the category of yes. So we'll have to make this some sorry, we have to make the simulated variable simulated visitors as equals to yes, right? And now with this, the null outcome, that the null outcome we are getting, we have to push all those values, the number of purchase values we have to pushed inside the, has to be appended or pushed inside the null outcomes. So in order to do the further calculation of the p values, right, we need to calculate. So our aim, what is our aim in the hypothesis testing? If you carefully understand, firstly we have to assume h naught and h naught and ha, that is null and alternate hypothesis. For the null hypothesis, uh, we have chosen that the probability that a visitor to that a visitor to a website makes a purchase is, let's say, 0.1, or let's say 10%. Okay, the total number of, let's say, 100 visitors visiting, so only 10 people are making the purchase. Let's say for Mintra, 100 people are visiting at Mintra website, or let's say Big Billion Day or Amazon, uh, whatever they call, they 10% people only visiting their website makes a purchase. Okay, so that is the null hypothesis. And what's the alternative hypothesis? That the probability that a visitor to a website make a purchase in less than 10. Okay, so these are mutually exclusive, right? Either they make 10%, either the purchase 10% people are making purchase, or less than 10%, right? There can't be both the cases, right? They these two statements can't be true simultaneously. That is what we are looking for, and that is how we define the hypothesis. Okay, so null and alternative hypothesis, these two are done. Now after this we need to calculate. Okay, the ultimate aim is calculation of p value, so that we can compare it with alpha, and we can comment on the null hypothesis, whether it is to be rejected or we fail to reject it. So if we reject it, alternate hypothesis is true. If we fail to reject it, null hypothesis is true. Okay, I hope you uh, I am clear with that as well. Cool, then let's quickly complete the last couple of lines we are left with. We just need to append all those values into null outcome. I have null outcome list. So null outcomes, I'll append that. Append the number of purchased items, number of purchase. Okay, purchased. Being careful so that I don't make any uh, silly spelling mistakes. So now what we'll do, we will calculate the p value. We'll calculate the p value. That is our final and most important part. So we'll convert this null outcome into the array, as you know, null outcomes to the array. So np dot array. That's why I was that's why we gone through the complete day one and spent our day one in studying Numpy, Pandas, and Matplot, so that you can plot the graph, you can convert them in array, you can play with all those things. Okay, right? That was the initial aim of my of our day one session. Okay, so Numpy dot array. Now I think you must be feeling comfortable with writing the codes for that. So it converts the null outcomes in the form of array, and then calculation of the p value. Let's define a variable with the name p value, and we'll give it a value of np.sum. Will sum, what will sum the null outcome, null outcomes. I'll explain you this, and the observed value as well. We'll take into consideration observed values as well. It's already defined. So, and one important thing that we are missing with is it should be, since it is a probability, so it should be divided with the number of null outcomes. So length is the function which gives you the number of null outcomes are there. Okay, so null outcomes are there. And once we are done with this, we'll go about and print this basically. So we'll print that p value of this case is equals to, let's say, p underscore value. Okay. Now let's see if the some error comes or how it works correct or not. Okay. Hopefully it should work fine. I don't see much mistake. Okay, num outcome is not defined. I think we have named this. Okay, this we have named it wrongly. Null outcome it should be. Num outcome is nothing. Num purchase is there. Null outcome is there. Yeah, p value. Okay, successfully it ran and p value comes out to be this. Now you can compare with the alpha, you according to your choice, the alpha according to your case, your client, your business holder, whatever alpha or level of significance they want. Like they say, okay, I want 10 purchase, 10%. Okay, so in our case we have assumed 10%. So it's that is null hypothesis is 0.01, right? Zero point 0.1. So the p value is less than that. So we'll reject the null hypothesis and we'll accept the alternate hypothesis, and thus we got the result. Okay, so that's how you implement the null hypothesis, and that's how we go about it. Okay, guys, and repeating it correct. Okay, you will get the recording. No worries. I think Karishma will provide you with the recording on the YouTube channel, and you can go through it once again. And if you have anything more, so yeah, Rohan, you can go through that and let me know in the chat as well, or in the on my LinkedIn ID or my mail, if anything you find after you have gone through the recording as well. Yeah, so that was the thing. So that was all, I think, from our side, from my side. Okay, I hope you got the idea. I'll quickly share. Give me 1 minute. I'll quickly share this with you. Dot this file with you, and so that we can. Okay. Yeah. Yeah. So this was day two, completion of the day two. So yeah, guys, that was all, I think. The YouTube channel link that Karishma would share. Okay, and yeah, over to you, Karishma. Thank you, guys. Thank you for being such a nice audience, and I hope you must have enjoyed and you have learned something new. And if you have anything, you can ask me on LinkedIn. You can chat us. Thank you, David. Thank you.